Okay, here's a video that would for us be from lesson 22, and it's question 12b. Um, and you can read the question off the lesson, but here's what it says. You have a plane, z is equal to 1, and a sphere of radius 2, and it has the center at the origin. So this is obviously not a three-dimensional picture, but it's what we would see if we looked at these two things edge on. Looking at the YZ plane. All right, so think of this as a cross section of what these would look like together on the YZ plane. Okay, so the issue is to find the volume as I shaded it. It's above the plane and also inside the sphere, and you're looking at it. And it says to use spherical coordinates. Okay, so we'll set up an integral for a volume, but everything is going to be done in spherical coordinates along the way. So let's do this. Maybe right here, let's jot down what the spherical coordinates to be in this region actually are. The easiest is, I think, theta, which, because this would have, there'd be points entirely around the z-axis, theta being a rotation on the xy plane would have to be between 0 and 360 degrees. Okay, simple enough. Theta is the easiest. The next is that I'd like to do is phi. Okay, so phi, what's phi? In spherical coordinates, phi is a rotation away from the positive z-axis. So if you were on the z-axis, phi would be 0. And then you rotate away from it wherever you want. And whatever that angle is phi. So here's the way it strikes me, that to be in this region that I shaded, phi could obviously be 0. All right, but I can't rotate. As far as rotating away from the z-axis, I can't rotate any further than that right there. Okay, if I were to rotate this far this way, I would be right on the border. If I rotated that same amount the other direction, I would be right there. Well, no matter how you rotate away from the z-axis that far, you're just almost outside of the region. So that's going to be my, whatever that angle is, that's my upper bound for phi. So here's what I did. I happen to have drawn this perfectly, and note that if that sphere has a radius of 2, this point would be a distance of 2 like that. And if that plane is z is equal to 1, then it's right there at 1, right in the middle, just like I drew it. So however I measure this should be accurate, and it measures out to 30 degrees. Okay, so for now I'm going to say that. And let's say, look, that was 30, so the rotation away from the z-axis is as much as pi over 3, okay? Okay, so pi over 3. Because if that angle right there is 30, that means that this is 60. And that's the rotation away from the z-axis, which is what phi is, okay? All right, so to keep me in there, theta is from 0 to 2 pi. Phi is from 0 to 60. All right. So let's think about it like this. Okay. What's next? Rho. Okay, so what's rho in spherical coordinates? Rho is such that once these angles are established, rho is the radial distance you go out in the direction established by the angles. So I might look at it like this. We can, if you want, imagine that we've got our angles. All right. And it puts us, out that way. I could call this d rho. I think about the boundaries for rho. And I noticed that I enter, no matter what, I enter this region through that plane, and I exit through the shell of the sphere. So, rho's got to be between, however far it gets you to here to however far it gets you to there. Well, I think that one's the easiest. I mean, if I have a sphere of radius 2, every single point on it has a distance of 2 from the origin. That's what rho is. Spheres with the center at the origin have a real simple equation in spherical coordinates, and this one would be that rho is 2. But the plane's a little bit different. How am I going to express the plane? Well, let's see. That says the plane z is equal to 1, and I might look at any conversions that we have, and I guess that's the one I need. Z is rho cosine phi. So let's think about it like this. To express how far it is to that plane, then I'll say rho cosine phi is 1. And I could give you that in terms of rho. If I knew phi, I could tell you how far it is to get to that plane. It would be that rho was the secant of phi, 1 over cosine phi. Does it make sense that the distance to that plane right there depends on how far you rotate away from the z-axis? It makes sense, I mean, because with phi set like that, that's how far it is right there. The further I rotate, the further it seems I have to go out. Yeah, so this just expresses that dependence. Okay, so let's do this. Let's put secant phi has to be less than rho, but rho has got to be less than 2. It's got to be somewhere in between. So there you go. Those are the spherical coordinates that will keep me here. Those must be the bounds of my integration. So say I set something up for the volume of that space that I've already drawn. In spherical coordinates, I have a triple integral. And if I want a triple integral to measure the volume of something, that needs to be a 1. And this is the volume differential for whatever coordinates you're using. If it was rectangular coordinates, if everything was measured in terms of x, y, and z, I would say some combination of dx, dy, dz. In spherical coordinates, the volume differential is rho squared sine phi d rho d phi d theta. Okay, so that's appropriate then for what I'm looking for. And I guess the boundaries here match the order of integration. So this is going to be, rho is from secant phi to 2. Phi is from 0 to pi over 3. And then theta is 0 to 2 pi. Alright, and the integral is set up. There's nothing more to do besides work it. And to work it from here, it doesn't matter what kind of coordinates you have. Rho is a variable that you integrate with respect to first, and you do that however you would handle rho squared, and then phi, and then theta. Okay, so let's do this one integration at a time. I go from secant phi to 2 rho squared sine phi. And that's with respect to rho. Okay. How would we handle that? Well, phi would be a constant. You know, everything except rho is a constant here. So I'm just going to get rho to the 3rd power over 3. And I just carry this constant, what at least for now is a constant sine phi. Okay. I substitute 4 rho secant phi and 2. Alright, so about that, I get what I think is pretty obviously 8/3 sine phi. Okay, minus, well, let's do this. Let's say 1/3 secant to the 3rd power phi. Okay. Then times sine phi. Alright, so there we are. Now about this, I carry that in the next step. Alright, integrate it with respect to phi, with the bounds that we agreed on up here. But let's do this. I don't have a problem with that first thing. 8/3 sine phi. No issues with that. This I have an issue with. I'd like to change that into something that I know how to do. So here's what I'll say. I'll say I have a negative 1/3. That is the same thing as cosine minus 3 power phi sine phi. Okay, I get all that. I like that a lot better. Okay, so that's the way I think I'll do it. Now, let's see, why do I like it better? Well, because that's a fairly simple u substitution. If u was cosine, that would be u to the minus 3 power. Du would be minus sine, okay? Alright, so that's u substitution, which we've seen so many times before, and this isn't even that hard. Antiderivative of sine is minus cosine. So here's what we get. Let's say negative 8/3 cosine phi. And if we carry through with that u substitution as I described, we'll get negative 1/6 cosine minus 2 phi, like that. Okay, and how do we want to do that? That was 0 to pi over 3, 0 to 60 degrees. So 0 to pi over 3. How that works out? Well, this will be, okay, so I'll get a half. Let me write negative 8/6, which I can reduce, but I don't see the need to. Well, 1/6 times cosine squared, that's what that is. Cosine of pi over 3 is a half. You square it, it's a fourth. You divide, you get 4/6. Okay, so that's what this gives me. And then the 0, well, I would be subtracting whatever the 0 gave me, and I'll be subtracting negative, so that's going to amount to this. And I'll get cosine of 0 is 1, I'll get 8/3. And same thing here, I'll get 1/6. Anyway, so I get that. Grand total, so that's negative 12/6. That would be negative 11/6. And that's 16/6. So I get 5/6. Okay, so we're done with that. Now, but this part should be easy. Say you've got that constant 5/6 integrated with respect to theta, 0 to pi. Well, this is just a constant. So if we do the third step, that last integration, it's going to be 5 pi over 3. Okay, and I set it up to measure volume. I'll give you some units to tell you that that's what that number means. And there it is.